My name is Will Richardson, and this is my proposed design for the Thornton B-Wing drainage system in Engineering Way. Okay, so the main functions that my new design tackles are instituting a new handicap ramp, alleviating the volume of runoff that is causing all this flooding, and filtering the runoff of sediment and pollutants before it enters our overall water system in a sustainable yet aesthetically pleasing manner. So right here are existing features. We can see the trees are pictured, existing sidewalk follows this hashing right here, and the utilities, stairs, and existing storm drain are pictured. Now, if we analyze it using FlowPath, we can see how water actually follows these elevations, and you can pretty much picture the source of all this flooding as it comes down and pools along these sidewalks, making it very difficult to traverse as a pedestrian. So my design helps mitigate all of this flooding through the use of 2 rain gardens with new elevations and built-in retaining walls, a brand new gutter and drainage system, and semi-permeable sidewalks. So here's a very basic plan view of my design, and pictured are the 2 rain gardens right here. There's this rain garden, which is upper and level with the higher sidewalk up here. And then this lower rain garden, which continues along Engineering Way, is actually level with the lowest sidewalk, which is the vehicle access at the bottom. As you can see, here's the ramp. The ramp design right here goes from the sidewalk up to the MECI building. And in general, the sidewalk and stairs sort of maintain their general shape because there have been no issues. It's very good for the flow of pedestrian traffic as is without the flooding. And so we're going to isolate the ramp and talk about the ramp for a little bit. So as you can see, it's a very straightforward design. We decided that there was no need to continue the ramp up all the way up through the stairs of the MECI building because there's already a pre-existing ramp which allows the handicap to access the building from this height of sidewalk. And I chose a 5% grade, which is within the ADA requirements, not a very steep slope, and it actually makes for a very easy cut and fill along the existing surface if you look at the profile view right here. Okay, so now we're going to talk about the gutter and drainage system, which is pictured in blue right here. And there will be more details to come in the profile view, but this gives a plan view schematic of it. And so you can see we introduced actual gutters on all the sidewalks, which is very useful and very needed, given the lack thereof right now, which causes all this flooding. So the actual gutters, and combined with a sloped sidewalk, which slopes towards the gutters from the center, will allow the water to enter these drains, which are pictured with these little blue ellipses, and they will go from the drains either into the rain gardens, where they will be filtered through the different layers and back into the lower soil, or from the bottom here, they will actually go into the pre-existing storm drain system. So we can pull up that section view right now. And so here's the section view right now. We can start with the gutters. You can see right here, these are the drain pipes. The gutters are on either side of the sidewalk. And the gutters will either deposit into the rain filtration system right here, which I'll go into later, or into the existing storm drain system, which I've simply represented with a rectangle. Now the rain gardens right here, I'll zoom in on this right here, if it'll load. They absorb the runoff and rainfall and actually help purify the water before it enters the water table by going through these various layers. So right here we have a prepared soil mixture of primarily sandy soil and soil which will be taken from the cut of this lower rain garden, and then a gravel reservoir. So the water will actually travel through here and through the root systems of these plants, and a lot of the pollutants and sediment will be caught within the garden and eliminated before entering the water table. Now another important note has to do with the vegetation on top. So we are getting rid of all the pre-existing trees in the current design and replacing them with smaller but more practical plants. So right here I very crudely represented the plants. However, the inner plants, as they'll be handling more of the rainfall as it enters the center, they'll be more suitable to wetter climates, whereas the plants on the outside are more suitable to drier climates and will not have to deal with the excessive rain flow as the central plants. Okay, now finally, I'll talk about the sidewalk design. As I mentioned, they are semi-permeable, and this allows some of the excess rain flow to enter through the sidewalk down here and either go through the gutter system or just down into the soil below. And so right here, the top surface, it's very crudely represented again, but actually between concrete pavers there will be semi-permeable materials which will allow rain to seep through. Once it seeps through, just like the rain gardens, it'll direct runoff underground rather than to the drains or to the surrounding pedestrian areas. So actually we can get it right here. So we have the base reservoir, just different materials, allowing the water to go through smoothly and receive some kind of filtration. And then right here, if you look closely, there's actually an under drain, and this under drain will direct some of the, it's perforated, allowing some water to collect in it, and this under drain will direct water into the gutter system, and the rest can seep through into the ground. And so that is my design, and I firmly believe that it will help mitigate the extreme flooding that has caused a lot of trouble in the last few years. Thank you for your time. That's all.